Hello guys, welcome back to EC TechNest. In this lecture, we'll be discussing about image transform. So what is image transformation? Image transformation is a mathematical expression or a tool where we'll convert the image, one image to another image, and the matrix is represented by n cross n, and both inverse as well as transform is inverse transform as well as transform is available for the image transformation. So input is an image of size of n cross n. After that, the image is transformed and we get another image of size n cross n. So given the transformed image, we can obtain the original image by applying the inverse transformation. After transformation, the image is called the transformed coefficient matrix. And why do we need transformation is another important thing that we need to study. So image transformation has a variety of applications such as pre-processing, data compression, and feature extraction. In pre-processing, it is further divided into filtering and enhancement, whereas in feature extraction, it is divided into edge detection and corner detection. In the case of image pre-processing, if the image contains noise, then we can find the contamination of noise, and that gives rise to high frequency components in the image. So if by using transformation we can find the frequency components in the image, then we can also suppress the high frequency component and take the inverse transform to get the image which is filtered. In image enhancement, if the image is blur or the quality of the image is not good, we can apply transformation to improve the quality of the image. Next is data compression. By transformation, the compression can be achieved, in which we are reducing the size of the image. So what does image transformation do? It represents the given image as a series of summation of set of unitary matrices. So let A be the matrix and A is a unitary matrix. If A inverse is equal to A star of T or A star transpose, then A star is the conjugate of A. So unitary matrices are used in the basis images. One-dimensional transforms are available. Now we'll discuss about one-dimensional transform. In one-dimensional transform, the sequence is represented by U of n, and the value of n varies from 0 to n minus 1 with the value with the size of n. And next, U of n can be represented in the form of a vector, that is V vector is equal to A into U vector. A vector is n cross n in size, that is the A matrix is n cross n in size. Vector V is transposed matrix, and A is the transformation matrix, which is unitary in nature. And now we are expanding this equation. So as we have values of n to be between 0 to n minus 1, we'll perform summation for n is equal to 0 to n minus 1, and A of k comma n into U of n, where the value of k again varies from 0 to n minus 1. Since A is a unitary matrix, A inverse is equal to A star transpose or A conjugate transpose. And now we'll replace the equation, that is vector U is equal to A inverse of V, and here A inverse is represented as substituted as A star A conjugate transpose. And now after expanding the equation, it will be in the form of U of n is equal to summation k is equal to 0 to n minus 1 into A star of k comma n and multiplied by V of k. Here value of n varies from 0 to n minus 1. So A star of k comma n is called the basis of A, and this basis vector is orthogonal if and only if the value of I equal to j, that is ai dot aj will be equal to k if I equal to j, and it will be 0 if I is not equal to j, and if k is equal to 1, then it is orthonormal in nature. Next we'll discuss about the two-dimensional orthogonal and unitary matrix. Similar to the previous one, in this previously we discussed about one-dimensional unitary matrix. Now we'll discuss about two-dimensional. that is u of m comma n is the image, and v of k comma l is the matrix that is represented by the equation summation in m comma n is equal to 0, varying from 0 to 0 to n minus 1, and a of k comma l comma m comma n multiply by u of m comma n. In this, the value of k and l will lie between 0 to n minus 1. Now we are replacing these terms by their conjugate, that is a of k comma l is replaced by a star of k comma l of m comma n, and a of k comma l is called the image transform, and it will satisfy the following properties. So the first one is orthonormality. In orthonormality, m comma n is 0 and varies from 0 to n minus 1, and a k comma l of m comma n into a conjugate of k dash comma l dash over the region m comma n is represented by sigma of k minus k dash comma l minus l dash. And next is completeness. In completeness also, we are considering the m and n values, that is the axis values. So here we have a k comma l of m comma n and a star of k dash l dash of m dash comma n dash. It is represented by sigma of m minus m dash comma n minus n dash. So this is how you represent the two-dimensional orthogonal and unitary transform, and it is further represented in terms of their transform coefficient, also called as the transformed image. So u cap of m comma n is represented by k is equal to 0 to p minus 1 and l is equal to 0 to q minus 1, and v of k comma l and a star of k comma l of m comma n, and after minimizing it will become the sum of square errors, and final equation would be zeta e square is equal to summation m comma n is equal to 0 to n minus 1 u of m comma n minus u cap of m comma n the whole square. So this is the sum of squares error. Error will be minimum if p is equal to q equal to n. And next one is separable uniform unitary transform. The number of multiplications and addition that is required to compute the transform coefficient v k comma l would be o, that is the complexity o of n power 4. That is, this computation is very large and practically and for practical sizes of image. So if the transform is restricted and separable, we are considering a k comma l of m comma n to be a, we are splitting it into a k of m into a l of n. It will be approximately equal to a of k comma m and b of l comma n. So these are 1D transforms, that is a k of m and a l of n. So the complete orthogonal set is formed by considering two-dimensional basis vectors, and final equation would be v is equal to a into u into a transpose. And now we'll move on to the problem. Also another important equation would be v is equal to a transpose into u is equal to a transpose a conjugate transpose into v into a conjugate. So this is one very important problem that's asked in many exams, also in VTU exam. They'll give the question or the matrix A, and along with that the value of matrix U will also be given. They'll ask you to find the transformed image and also apply inverse transform to find the original image. So first, to find the transformed image, we have to consider the equation v is equal to u into a into u into a transpose. Remember and also keep in mind that the order of the variable should not change because we are multiplying term by term. So first we'll consider a into u into a transpose. So write down the values. A is 1 by root 2 1 1 1 minus 1 multiplied by u, that is 1 3 2 and 4. Next it's multiplied by the transpose. Transpose would be as you have already studied in max also, transpose would be rows will become columns and columns will become rows. Then first you have to multiply these two terms, that is A into U, and then from the product that's obtained you have to multiply it with the A transpose. After multiplying with A transpose, you will get the final value V is equal to 5 minus 1 minus 2 comma 0. Next you have to obtain the basis image for each term, that is A00, 01, 10 and 11. For A00 star you have to consider 1 by 2, and you have to consider the first column and first row, that is 1 1 and 1 1. And when you form the matrix it will be 1 by 2 of 1 1 1 1. Similarly for A conjugate of 0 1 you have to consider the second row, first column and then second row, so you'll get the following matrix. After that you have to repeat the same for 1 0, you'll get the matrix, and again you'll repeat it for 1 1. After you get the matrix, you'll perform inverse transformation to obtain back the value of U. If you correctly get the value of U, then you can verify that the whole problem that you have solved is correct. So after you consider the equation to be V is equal to A conjugate T into V into A star. Now you'll consider A conjugate T, 1 by 2 into 1 1 1 and minus 1. After that you'll replace the V value. V value is already obtained here, that is 5 minus 1 minus 2 and 0, and then replace the A star. A star would be 1 1 1 minus 1. When you multiply the first two terms you'll get the product. After that multiply the same product with 1 1 1 minus 1, you'll get back the original image. So U is equal to 1 2 3 4. This is the original image. Similarly in exam also they'll ask the same question, or they can change the numbers. Your main objective should be you have to get back the same answer. Of main trick used in this question is you have to obtain the same answer, that of the matrix U, then your problem is solved and you have done it correctly, is the hint or trick that you use here. So further we'll discuss in the next lecture.